On January the 1st of 2017, I was looking at the moon with a robotic telescope, getting some video for a project student of mine who was studying impact flashes on the moon, and lo and behold, I discovered somewhat later that we had recorded an impact flash, a little brief flash of light on the night side of the moon, lasting just a fraction of a second. The size of the object which hit the moon was probably fairly similar to this little bit of rock I have here. And that would have been travelling at several tens of kilometres per second, and it suddenly hits a surface, that's the surface of the moon, and produces a crater maybe about 2 or 3 metres across, and about 1%, just tiny, less than 1% of the energy of that object hitting the moon gets converted into light. We're studying the moon to get an understanding of how many meteorites strike the surface in the present era. In the past there were a lot more meteorites hitting the moon producing giant craters, but now it's petered out quite a lot. But it's important to know what the present impact rate is on the moon, because this can affect how they build moon bases in the future or exploration missions on the moon, knowing how thick the shields need to be on spacesuits or on moon bases. We can date the surface of the moon like with tree rings. With the tree, the more tree rings it has, the older it is. With the moon, the more holes on the surface produced by meteorites coming in, the older it is. And we've got a fairly good handle on some of the earlier times of the moon, but it's not so good at present times because there's so few meteorites coming in that the statistics aren't good. So by observing these impact flashes on the moon, we learn a lot about the present day impact rate, and it helps us to date more recent surfaces on the moon.